Anybody way won't fight you, man, they come, they already know. I'll be right beside you.
I welcome you back on the continuation of carbon and its compounds. Thank you for following me. My channel is Smart Science. I urge you to continue subscribing and watching these videos such that you make the best out of it. You've learned in the recent O-level results that English and chemistry were the worst done across the country. Good enough at our station. Chemistry is not that alarming, so we try as much as possible to learn through these channels such that we don't have any bad scenario along the way. Our last upload was about preparation of carbon dioxide, which we discussed. Today we are here to discuss the reactions and the properties of carbon dioxide such that we can proceed on other areas of interest. So today we are looking at properties of carbon dioxide. That is our area of interest in today's discussion, and hopefully everyone will try to understand whatever we are talking about here. Properties are always categorized into two. There are those which are physical and there are those which are chemical. The physical properties don't involve equations, but the chemical properties will involve equations. So definitely we are to begin with the physical properties. Among the physical properties, there are things we commonly look at like color. We all know carbon dioxide is part of air and air cannot be seen. So definitely expect carbon dioxide to be colorless. Two, you cannot smell it. Therefore expect it to be odorless. Three, we all know this carbon dioxide does not support burning. That's why it's used in fire extinguishers. So it doesn't support burning. And because of this property, it's thus used in fire extinguishers because it cannot support burning in any way. You can collect it over water, reason being it is slightly soluble. It is slightly soluble in water, and when it dissolves, part of it dissolves, it forms carbonic acid. This acid is weak and it's one acid that causes hard water. I think you saw it in the previous uploads on hard water, that if the weak carbonic acid can dissolve limestone if it falls under limestone areas, and it causes hard water. So carbon dioxide is a little bit slightly soluble, and when it dissolves, it's going to give us carbonic acid. This carbonic acid can be represented, its formation can be represented by an equation where water in the atmosphere, especially rainwater, mixes with carbon dioxide gas in a reversible reaction to form a weak carbonic acid, which is aqueous. And this acid, if it happens to fall under limestone areas, it will eventually cause temporary water hardness. This gas, carbon dioxide, is acidic. Therefore, it turns blue litmus paper red. Thus, it is an acidic oxide. This is discussed under oxygen, classes of oxides, and you must have looked at the fact that carbon dioxide is an acidic oxide as indicated by that property. As we proceed, we don't have only physical properties. So as we conclude the physical properties, you saw the method of collection, that carbon dioxide was collected by downward delivery. So since it was downward delivery, expect it to be more dense than air. And because of this property, it is therefore collected by downward delivery. More dense than air, therefore collected by downward delivery. These things we saw when it comes to preparation. We saw these things under preparation of carbon dioxide, and hopefully everyone has understood the physical properties. It's now high time we cross to the chemical properties and looked at how carbon dioxide behaves with other compounds or other elements. So part B, let us look at the chemical properties. Chemical properties of carbon dioxide. And the most common chemical property is reaction with magnesium. Reaction with magnesium. When you lower a piece of magnesium into carbon dioxide, however much carbon dioxide does not support burning, the burning magnesium ribbon will continue to burn. Because when you look at the formula of carbon dioxide, it contains oxygen, and magnesium has a higher affinity for oxygen. So it's going to continue burning, and the magnesium will decompose the carbon dioxide to carbon and oxygen. So magnesium will burn with oxygen, and carbon will be let to go. So as we are trying to describe this, the burning magnesium ribbon continues to burn in carbon dioxide to form a black soot of carbon and a white ash of magnesium oxide. This is possible because this is due to a magnesium having a high affinity for oxygen, And because of the high affinity of magnesium for oxygen, heated magnesium will decompose carbon dioxide. Thus, heated magnesium decomposes carbon dioxide to carbon and the oxygen. So the oxygen will burn with magnesium, and magnesium will form magnesium oxide. When it comes to the equation representing this reaction, our magnesium, which is a solid, will burn in carbon dioxide, which is a gas, to form magnesium oxide, which is a solid, and carbon. This carbon will be in form of soot, which is also represented by a state of a solid. When it comes to balancing our equation, oxygen is 2, but here oxygen is 1. So I'm multiplying magnesium oxide with a 2. Magnesium becomes 2, therefore I multiply that magnesium with a 2. And I conclude my equation concerning burning of magnesium in carbon dioxide with that. However, I would like to continue looking at this equation and emphasize the following: that in this equation, carbon dioxide is behaving as an oxidizing agent. And magnesium is behaving as a reducing agent. That's why we are seeing that carbon dioxide is oxidizing magnesium to magnesium oxide, and it's itself reduced to carbon. In this equation, therefore, magnesium is being oxidized while carbon dioxide is being reduced. Because of that, the equation is going to be called a redox reaction. Why? There is both oxidation and reduction taking place. So that's one property of carbon dioxide, and it emphasizes reaction of magnesium with carbon dioxide. Question approach. If I give you this equation, mostly it's like you're burning a candle. The carbon is going to come off as smoke. So if I tell you the solid product was dissolved in water, always dissolve magnesium oxide in water, because this carbon, however much it's given off, it is given off as smoke. You are not going to collect it and dissolve it in water. So if I say dissolve the solid product in water, always dissolve magnesium oxide only. If I call for an observation, the observations have been earmarked in our description. So we have white ash and a black soot. That is the observation. If we say explain your observation, the explanation is in this paragraph. That's why magnesium reacts with carbon dioxide. So try to make sure that it's not only looking at the matter, the content, but how do we apply it when it comes to question approach. Let us look at the second chemical property of magnesium. Of carbon dioxide. The other chemical property I'm going to look at is reaction with lime water. So 2 is reaction with calcium hydroxide. This one is also called lime water. When it comes to this property, it also acts as the test for carbon dioxide. So when we bubble carbon dioxide through lime water, this lime water will develop into a white precipitate, or it will turn milky. Sometimes people tend to call it milky. So when carbon dioxide is bubbled into calcium hydroxide, a white precipitate is formed. The white precipitate is going to be formed. This white precipitate, sometimes they are just going to say lime water turns milky. Sometimes you're going to find this. Lime water turned milky. The explanation for formation of a white precipitate is due to formation of an insoluble calcium carbonate. The calcium carbonate formed when carbon dioxide is bubbled through lime water is insoluble. Therefore, it gives us a white precipitate. We discussed some of these things when we are talking about water, hard water, and how can it be removed. So we saw the role of calcium hydroxide in removal of water hardness. And therefore, as I'm talking about this property, try to refer to the same to another video for hard water and see methods of removal of water hardness and see how these 2 points are related. So calcium hydroxide, by show of an equation, reacts with carbon dioxide gas, and the resultant is going to be calcium carbonate. Because it is insoluble, we are representing it with a liquid state, a solid state. And lastly, water. Make sure whichever equation you write is balancing. Calcium is 1, calcium is 1. I move on to the next atom. Oxygen. Here there are 2 plus these 2, they become 4. When I cross the arrow, I'm having 3 plus 1, they are 4. Hydrogen is at 2, hydrogen is at 2. Carbon is 1, carbon is 1. So my equation is balancing. And as it balances, calcium carbonate is viewed as a white precipitate. Precipitate, abbreviated as PPT, but never abbreviate it when you're answering questions in papers. Abbreviations should only be important in our notes. As we continue, if they tell you pass more carbon dioxide through this product, when more carbon dioxide is bubbled through the white precipitate, dissolves to form a colorless solution. The solution will form due to, if they call for an explanation, due to formation of a soluble calcium hydrogen carbonate. You're seeing that what I'm writing here requires us to be knowing the knowledge of soluble and insoluble salts. So I will emphasize that people should try to get to know those properties, and I will make videos concerning salts and acids plus bases. So when I'm to represent this with an equation, calcium carbonate in presence of water reacts with carbon dioxide gas to form calcium hydrogen carbonate, which is represented by aqueous state because it is soluble in water. Make sure your equation is balancing. Calcium is 1, calcium is 1. Carbon, we have 2 carbons, this and this. Likewise, carbon here has been multiplied by 2. Hydrogen is 2, hydrogen has been multiplied by 2. Oxygen, I'm having 3 plus 1, those are 4, plus 2, those are 6. The 3 have been multiplied by 2. So we are going to be observing calcium carbonate as a colorless solution. This property can be applied in the lab. It can be applied by you. How do you apply it? Application of this property. Practical application. Practical application is test for carbon dioxide gas. If you want to confirm that the colorless gas you're seeing is carbon dioxide, then just bubble it through lime water. You can identify that, sincerely speaking, this is now carbon dioxide. And you can continue using carbon dioxide in other areas where it can be used. So that marks reaction with calcium hydroxide. We are to proceed with other chemical properties of carbon dioxide. I'm looking at the third property of carbon dioxide. Property number 3. Let us look at reaction with other alkalis. Alkalis are many. Let me say especially sodium hydroxide or potassium hydroxide. I will look at those alkalis in particular and how they react with carbon dioxide. To understand this reaction better, you need some knowledge about solubility of salts of sodium and potassium. I will remind you that both sodium and potassium carbonate are soluble in water, but sodium hydrogen carbonate and potassium hydrogen carbonate are insoluble in water. So when you bubble carbon dioxide through sodium hydroxide or potassium hydroxide for a short time, nothing is going to be observed. But with excess, you're going to see something. So as we continue describing our property, when little carbon dioxide is bubbled through sodium hydroxide or potassium hydroxide, there is no observable change. Why no observable change? Due to formation of soluble sodium carbonate. If it is not sodium, we say it is going to be potassium. So all potassium carbonate. And since those two are soluble, cannot observe anything. By show of an equation, sodium hydroxide, which is aqueous, reacts with carbon dioxide, which is also aqueous, a gas, which is a gas, to form sodium carbonate, which is aqueous plus water, which is a liquid. Balancing the equation, sodium is 2, so I'm multiplying sodium by 2. Oxygen becomes 2 plus these 2, they are 4. I'm seeing 3 plus 1, 4. Hydrogen is 2, hydrogen is 2. So my equation is balancing. If it is potassium hydroxide reacting with carbon dioxide gas, we are to form potassium carbonate, which is also soluble, plus water, which is a liquid. The same values balance the equation. So in that case, nothing is going to be observed. Why? Because the two salts formed, both potassium and sodium carbonate, are soluble in water. So they are not going to give us anything. However, when you bubble excess carbon dioxide through the two alkalis, then you're going to be able to see something. As we continue, when excess carbon dioxide is bubbled through a white precipitate, is formed. Why? The reason is due to formation of an insoluble sodium hydrogen carbonate. If not sodium, it's going to be potassium hydrogen carbonate. Because those two salts are insoluble in water. With an equation to represent what I've said here, we are going to see to it that if in these products where you have sodium carbonate and water, you bubble carbon dioxide through, you're going to form sodium hydrogen carbonate, which is a solid. Since sodium is 2, I'm multiplying sodium hydrogen carbonate by 2. Hydrogen is 2, even here hydrogen is 2. Carbons are 2, even here carbon has been multiplied by 2. Oxygen is a 6, even here the 3 have been multiplied by 2 and they are 6. So we are going to see this as a white precipitate because that salt is insoluble. Likewise, if potassium carbonate, the mixture of potassium carbonate and water, we bubble carbon dioxide through, we are going to form potassium hydrogen carbonate, which is a solid. The same value will balance, and the same observation, because this is a white precipitate. Sometimes the two equations, this category and this category, can be combined in one overall equation where I have sodium hydroxide aqueous reacting with carbon dioxide gas, directly giving us sodium hydrogen carbonate, which is a solid. All potassium hydroxide aqueous reacting with excess carbon dioxide, directly giving us potassium hydrogen carbonate, which is a solid. So these last two equations have both this category and this category combined together, and we form only one overall equation representing reaction of alkalis with carbon dioxide. So when you have your sodium hydroxide and you leave it exposed to air, later on you're going to find a white precipitate forming. Why will the white precipitate form? Is due to formation of sodium hydrogen carbonate, which is insoluble and appears as a white precipitate. Lastly, on carbon dioxide are the uses of carbon dioxide. How can we try to use it in daily life? Uses of carbon dioxide. Do we need it really in daily life? How can we appreciate the fact that God created carbon dioxide, and how do we assimilate it in our day-to-day life? This carbon dioxide is used in manufacture of carbonated drinks. So that's number one. Used in manufacture of carbonated drinks. E.g. soda, etc., beer, etc. It acts as a preservative. You've seen sodas, when you open, there is that hissing sound that comes out, and lather sometimes forms as carbon dioxide is escaping. So it is used, number one. Number two, it is used as a refrigerating agent. Used as a refrigerating agent for perishable goods. Especially fish. So instead of using ice from water, they use iced carbon dioxide because it does not melt. Remember, carbon dioxide doesn't melt, it just solidifies or turns to gaseous state. So it's just subliming. So to prevent melting of that ice used to transport fish. We use carbon dioxide, and life continues. Number 2, solid carbon dioxide. Sometimes it is dropped into clouds to trigger rain. This one is commonly used by the Chinese, and basically the Chinese and these agriculturalists, basically in Netherlands. So they use this format of triggering rain, such that rain starts and life continues. So we can say that solid carbon dioxide is dropped into clouds to cool them to form rain. And that is how far the world has gone. That nowadays we don't depend on natural things only, but sometimes we induce occurrence, we induce climatic conditions. So if you feel like you need rain nowadays, like the drought is so much, you just have to get the carbon dioxide and drop it into clouds. The clouds will freeze, and definitely you will receive rain in a few minutes. 3, used in fire extinguishers. Used in fire extinguishers to put off fire. And this property is backed up by the fact that carbon dioxide is denser than air. Because it's denser, thus forms a blanket that blocks off oxygen. 2, it does not support burning. So it puts off oxygen. Oxygen can no longer come near fire, and fire definitely has to be put off. The same gas is used by plants in photosynthesis. And life on Earth is sustained by that process of photosynthesis. Minus photosynthesis, definitely no one can survive, because all the food we eat is connected to photosynthesis. All the food we eat is either from plants or herbivores. Herbivores which eat plants. So minus plants we cannot survive, because all the food we need comes from them. The sugar we need comes from carbon dioxide, and definitely which is used in photosynthesis by the green plants. And lastly, among the uses, it's used in manufacture of sodium carbonate. People who prepare things for baking. Used in manufacture of sodium carbonate. If you prepare things that are baked, the baking powder you use is sodium carbonate. So we need it in daily life. If you want to prepare half cakes, so on and so forth, chapati, among others, you have to use sodium carbonate as a raising agent. Or if you to prepare maybe bread, is when you use yeast as the raising agent. But these are the things that need to be baked. We use baking powder, which is sodium carbonate, and it acts as the raising agent. So that marks the end of carbon dioxide. The other oxide of carbon is carbon monoxide, which we are to look at in the next upload. I would request you to continue subscribing to my channel, because these videos are going to be uploaded at least frequently, such that we complete one topic and handle another. And at the end of the day, I would like you to appreciate the use of such knowledge after you've seen a progress in your academics. I thank you very much for attending. Wait for the next upload very soon. Thank you very much.